cancer. Just hearing the word brings a mix of emotions: fear, sadness, sometimes anger. It's a battle fought by millions, and despite countless advancements in medicine, a cure seems just out of reach. But why is that? Today I want to take you through the scientific facts, the complex challenges, and the groundbreaking research that brings us closer each day. Let's dive in together with hope and understanding as we explore why cancer remains one of the toughest puzzles of our time. To understand why cancer is still unsolved, we first need to understand what it is. At its core, cancer is a disease where cells in the body begin to grow uncontrollably. Unlike healthy cells, which know when to stop growing or when to die, cancer cells ignore these signals. They don't play by the rules. And because of that, they keep growing, forming tumors or spreading to different areas of the body. But cancer isn't just one disease, it's a collection of over 100 different diseases, each with its own set of challenges. And that's part of what makes it so difficult to cure. Now, here's where it gets complicated. Every person's cancer is unique. Even two people with the same type of cancer might experience it differently. This is because our bodies are made up of billions of cells, each with its own DNA. When DNA is damaged, mutations can occur, leading to cancer. But here's the thing, those mutations aren't the same in every person. These genetic mutations can come from many things: lifestyle, environment, or just random chance. It's like every cancer cell has a unique fingerprint, and that makes it nearly impossible to develop a one-size-fits-all cure. You might be wondering, what about treatments like chemotherapy, radiation, or immunotherapy? We have these, and they work for some people, but they don't work for everyone. Chemotherapy, for instance, attacks rapidly dividing cells, which is why it's effective against cancer, but also why it comes with side effects, as it can't tell the difference between cancer cells and some healthy cells. Immunotherapy is promising too. It uses the body's immune system to target cancer, but even this revolutionary treatment only works in about 20% of patients. And that's another roadblock: these treatments aren't universal. One reason cancer remains so resilient is that it adapts and evolves. Cancer cells have a way of learning from the treatments we throw at them. They can become resistant to drugs, meaning that what worked initially stops being effective over time. Imagine trying to solve a puzzle that changes every time you get closer to finishing it. This adaptability is part of what makes cancer so challenging to conquer. Another obstacle: early detection. Cancer is easier to treat when caught early, but many cancers don't show symptoms until they're advanced. Think about pancreatic cancer. It's often not diagnosed until it's already spread because the early signs are so subtle. By the time symptoms appear, it may be too late for effective treatment. If we could detect cancer sooner, we'd have a better chance of treating it successfully. That's why scientists are working on tools for early detection, like blood tests that identify cancer markers or imaging technology that spots tumors when they're still small. So why can't we just find a single cure for all cancers? The truth is, because cancer isn't a single disease. As I mentioned earlier, every type of cancer and every person's cancer is different. Finding a universal cure would be like trying to use one key to open hundreds of unique locks. Each type of cancer behaves differently, spreads differently, and responds to treatment differently. Scientists are trying to understand each cancer type on a deep level to develop targeted treatments. But it's a long, challenging process. Despite these challenges, there is hope. Every year, researchers are learning more. Precision medicine, for instance, is a growing field that tailors treatment to each person's genetic makeup. This means that treatments could become more effective with fewer side effects. And then there's CRISPR, a technology that allows scientists to edit DNA. Imagine being able to remove mutations that cause cancer. We're still years away from using it widely in humans, but the potential is extraordinary. While we're waiting for those future breakthroughs, there are things we can do now to lower our risk. Research shows that lifestyle choices like not smoking, eating a balanced diet, staying active, and protecting ourselves from the sun can reduce the likelihood of some types of cancer. It's not a guarantee, but these choices matter. And each step we take toward a healthier life brings us closer to preventing some cancers altogether. So, why is cancer still unsolved? It's because cancer is complex, resilient, and unique to each person. But we're not without hope. Every year, every scientific breakthrough, every small victory brings us closer to understanding and controlling this disease. Let's continue to support research, take care of ourselves, and hold on to hope for a future where cancer is no longer such a powerful foe.